Hello, my name is Kevin Cavell and I'm a product manager at Agilent Technologies. Today I'm going to show you how to quickly charge an ultracapacitor using a power supply that has a high current capability. We have another video which shows the characteristics or gathering the characteristics of an ultracapacitor. In that video we use one of our N6780 SMU modules. This module has a maximum output current of 3 amps, so in order to charge the capacitor with this module, it would take a little bit longer. So we have some other modules in the N6700 family that have higher output currents, such as the one I have installed in the DC power analyzer mainframe. The one I have in here is the N6764A. That has a maximum current of 20 amps, and if you have that, you can actually charge a lot faster by sourcing 20 amps to the capacitor. But we have modules that actually go even higher than that. This is an example, the N6765A. You can see it has a very large output connector to handle the 50 amps, so you can actually charge faster with this one if you wanted to use this one. Okay, so the device that we're going to charge today is a 310 farad capacitor rated at 2.7 volts. So again, that's 310 farads, not microfarads. I know as engineers we're all used to saying microfarads, but this is a very large capacitor, so a lot of energy. So you want to be careful when you set something like this up, make sure you're not shorting any of the leads. So what we're going to do is, this is discharged. We're going to use the DC power analyzer and the N6764A module to charge it. And we're going to use the data logger feature of the DC power analyzer to watch what it looks like as the current goes into the capacitor and the voltage will start to raise. So I have everything set up in the data logger. We're going to do a data log of 60 seconds, so that'll continually measure the voltage and the current for 60 seconds. The module that we're using is of the Precision series, the N6760 series. It actually has 2 built-in digitizers, so we can measure voltage and current simultaneously. So we can also calculate the power and look at what that's like. But since this is just a charge, we'll just look at the current and the voltage. So I'll start the data logger now by pressing the run stop key. At the bottom, we'll see the voltage and the current are being measured. Nothing's happening because the output is off. So if I turn the output on, we'll see the current, which is the top waveform, jumped up to 20 amps. And now the capacitor is being charged with that 20 amps of current. And you can also see the bottom waveform here is the voltage. The voltage is slowly being raised up to 2.5 volts as the capacitor is charged. And since this is a 310 farad capacitor at 20 amps, if you do the calculations, it's roughly 40 seconds or so before the capacitor is fully charged to 2.5 volts. Once it gets there, which is getting pretty close now, we should see the voltage or the current start to drop down now. And it'll slowly drop down continuously. Our 60 seconds that we set for the data logger is now done. It just gave us an indication of that, and it tells us that all of our data has been stored in the default.dlog file. If I hit enter, it'll clear that, and we can take another look at the data log. Again, the current was here at the top at 20 amps. Once it was fully charged to 2.5 volts here, you can see the current starts to drop down. And then this here is actually the voltage at 2.5 amps. Because we set the scale kind of too close to each other, it almost looks like this is the continuous waveform, but this is actually the current, and then it drops down, and this is the voltage. And once it gets to 2.5 volts, it stays up there at 2.5 volts. All this data is saved to the dlog file that was just shown to you, default.dlog. You can do all the post-processing that you'd like on this data. You can calculate the dVdt of the charge. You can anything you'd like to get. You have all the current and voltage points that you need in order to make those measurements. Again, We were able to do this very quickly because we were using a power supply that has a high current capability, so you can charge a lot faster. In the other video, the maximum current was 3 amps, so that's a slower charge than here. So this is just a way that we can use a higher power or higher current power supply to do faster testing. Thank you.